On the 14th of August 2003, a major widespread power outage occurred that affected major cities in the northeastern and midwestern states of the US and parts of the Canadian province of Ontario. The event, now known as the Northeast Blackout of 2003, affected up to 55 million residents and caused at least $4 billion of economic damage. It was caused by a combination of technical and human failures, leading to a cascading failure in the power grid.
On August 14, 2003, 3:05 p.m., a routine afternoon in Ohio became the catalyst for history's largest North American blackout. Overgrown vegetation protected transmission lines while faulty monitoring system missed the warning sign. Until 3:05 p.m. Ohio to 4:09 p.m. in Michigan and 4:13 p.m. to Northeast within 90 minutes, the failure cascaded across 8 states and Canada involving web backup system, and by 4:13 p.m. critical infrastructure failed across the entire Northeast region. The 2003 Northeast blackout triggered cascading failure across critical infrastructure systems. Emergency services were compromised as 9/11 system failed. Hospitals operated on backup power for 48 hours. Water purification systems were disrupted, requiring boil water advisory across multiple states. The event caused $6 billion in losses and exposed critical vulnerabilities in grid management. New reliability standards were implemented, but modern infrastructure remained vulnerable to extreme weather and cyber threats.
The North American blackout exposed serious engineering lapses. Firstly, inadequate tree trimming in Ohio caused sagging high voltage lines to contact with vegetation, tripping multiple lines and violating Regulation 24, which mandates the engineers act with diligence. Secondly, a SCADA software bugs disabled critical alarms, leaving First Energy operators blind to the worsening grid conditions, contravening Regulations 23 and 24 on system oversight. More critically, the power grid lacked resilience. Poor relay settings and the absence of islanding mechanisms allowed faults to cascade unchecked. This systematic design flaw breached Regulation 26, which stresses the public trust and safety in engineering. Overall, the blackout wasn't just a technical failure, it was a breakdown in professional responsibility, maintenance, and regulatory compliance under the Engineers Act.
There were various ethical reasons for failure. First is First Energy's failure to address the known risks of unmaintained foliage near their transmission lines, causing the Stuart Atlanta transmission line to trip its circuit breakers and thus overloading all the other nearby lines. This can be tied to BEM Regulation Section 25, Subsection 1, where a registered engineer should at all times regard the interests of the public, employer, or client as their top priority in their duties. Another major reason was the breakdown in communications among grid operators, as well as their delayed or insufficient response to the event, showing that there was a lack of transparency or lack of preparedness and training of the company. These failures are addressed by BEM Regulation Section 24, Clause C, which states that every registered person shall conduct themselves responsibly, ethically, and lawfully to uphold the honor and reputation of the profession, and Section 25, Subsection 2, Clause E, where a registered person should always inform his employer or client of situations that may endanger the public.
One major issue was outdated SCADA systems. Operators didn't get real-time alerts as power line failed. Upgrading these systems and adding tools like PMUs and WAMS allows faster response and helps prevent cascading outages. Another cause, overgrown trees. The first system failed when it sagged into untrimmed vegetation. That's why strict vegetation management with regular inspections and trimming is crucial for grid safety. There was also a lack of proper maintenance. Some alarms didn't work and equipment was outdated. Independent audits can make sure utilities follow standard and fix problems before it's too late. Finally, none of this work without ethics. Engineers must be trained to speak up, stay informed, and always put public safety first. The 2003 blackout showed how small failures like poor monitoring, overgrown trees, and missed maintenance can spiral into massive crises. It was a powerful reminder that no part of the power grid can be ignored without putting millions at risk. But it's not just about fixing technical flaws. Engineers have a responsibility to act ethically, to foresee risks, speak up, and always put public safety first. Moving forward, we need a proactive mindset, regular risk checks, proper maintenance, and independent oversight should be part of the everyday operations. That's how we protect our infrastructure and fulfill our duty to communicate with it.